So now we have 32 in, right, connected with us for this lecture. And I think in the last week we were talking about different aspects of data and how data are collected and what are the procedures and all these things. And today we'll be talking about how we do some preliminary analysis of the data that we have collected, right? Well, so let me share the screen with you. Right, so this is regarding presenting data in tables and chart. Okay, we will be talking about two things: how to present your data and how to do a preliminary analysis. We talk about in this lecture, right, how to perform, how to do a preliminary analysis using graphical summary measures and numerical summary measures. Right, so this is what we mainly talk about today. Right, so we talk about graphical summary measures. Right, so this is graphical part, graphical summary measures, and the numerical summary measures. And first we talk about, right, so this is what we talk about first. So this is the first thing. So we'll be talking about, right, presenting data in tables and charts. This is graphical summary measures. And this is graphical summary measures. This is graphical summary measures, right? Okay, these are the things that we will be discussing about graphical summary measures, right? So when the data are in raw form, so we will not be able to see the information in the data that we will use for decision making, right? So therefore, we need to organize these things somehow, right? So that we can do by using tables and graphs. That we can do by using tables. That we can do by using tables and graphs. The techniques that we will be talking about today, right, are these. So we'll be talking about bar charts and pie charts, Pareto diagram, right, ordered array, stem and leaf display, frequency distributions, cumulative frequency distributions, contingency table, and the scatter diagram. These techniques, right, the use of these techniques are based on the type of data. Whether they are qualitative data or quantitative data. The techniques that we used for qualitative data are usually not used to summarize quantitative data. We use different tools, tables, and graphs to summarize different types of data. We use different methods for different types of data. Right? This is what you should understand pretty well. Okay, let's first see. So what are the methods that we use to summarize categorical data? Right? So we usually use summary tables, right, to summarize categorical data, and graphs like bar charts, pie charts, and Pareto diagrams as graphical data. Okay, so let me explain certain important things that we compute with categorical data. First, to understand, right, before understand or before talking about tabulation of them and putting them in graphs, right? Please give me a few seconds, right? Few minutes. I'll get back to you, right, in few minutes. Let's see. Suppose we have collect data. Suppose we have collect data on the gender of a community. We have collected data on the gender of a community. So what is the type of this data? The type of this data, gender. So this is categorical data. එහෙම නැත්නම් nominal data. Data in nominal scale. Nominal data. Right? So you will look like data of gender like this. Male, male, maybe female, right? Male, female, 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 male, male, female, male, like this. You may have collected data. Right? And again, male, female, male. How many data points do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The sample size here equal 15. So this is a sample size. So now we can estimate frequencies. We estimate frequencies. So with categorical data, so we will estimate frequencies, right? Frequencies. Okay, now we can estimate frequency. So we have the level of X, we have males and we have females. And we can here put the frequency F. So this we can put in a table actually, right? We can estimate frequency. Okay, we will talk about the table later. Frequency of male. So we need to count how many males are in the sample. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 males, right? And similarly, we can estimate frequency of females, that is 7. So on top of this, right? On top of this, we can estimate some more things, right? The second thing is relative frequency. Relative frequency, right? So relative frequency is relative frequency. The relative frequency is frequency divided by n. N is the sample size, right? Relative frequency of male equal 8 divided by 15, right? 8 divided by 15. So this is the relative frequency of it. This equals 0.53. The relative frequency of female equals 7 equal divided by 15, that is equal 0.47. In addition, we can estimate some other thing which is called cumulative frequency. So that is the sequential summation of your data. Say we have education level data, say education level data. We have frequencies, right? We have high education, medium education, and low education, 3 levels. So we have frequencies, say, so we have now 10 here, and here there will be 30, and so there will be another number of, say we have low education, 10 low education people, right? So now we can get cumulative frequencies, right? The cumulative frequency, right, at here, cumulative frequency, right, of H is 10, only 10. The cumulative frequency here, right, H plus medium is 40. Cumulative frequency at low equal 50. So this is the sample size. So this is called cumulative frequency. Similarly, we can estimate cumulative relative frequency as well. Right. So please keep note at this. Okay. In tables, right? In tables, say, right? In tables, right? So we can summarize data by the categories. So we can summarize data of a particular variable. We can summarize data of a particular variable by different categories. Okay, look at this example. So this is a current investment portfolio of some community, say of an investor, of an investor. The current investment portfolio can be summarized, right? Can be summarized. So like this. So now we have two variables. In this context, we have two variables. Now there are two variables here. So now we have two variables here, right? So we have two variables. We have two variables here. The one is investment type. The second is investment. Amount invested, right? So this is the first variable and this is the second variable. So we can, summarize the amounts invested by different portfolios like this together with their percentages, right? Together with their percentages. Similarly, right? Similarly, we can summarize our gender data in a table. Similarly, we can summarize our gender data in a table, right? So this is gender type, frequency, relative frequency, cumulative frequency, cumulative relative frequency. So this is also one way, right, that we can summarize them, right? Male, female, total. So we have here, we had 8, 7, relative frequencies 0.53, 0.47. The cumulative frequency is 8, here 15, right? And cumulative relative frequency is 0.53, 1.0. So we can do it like this. We can summarize data. Here we have one categorical variable, right? Here we have one variable. In the previous case, we had two variables. So these kind of data, right, summarized in a table, can be put in a chart as well, graph as well, right? So these graphs are usually, right, bar charts and pie charts. So in bar charts and pie charts, right, so usually, right, so we use these bar charts and pie charts usually to summarize qualitative data, categorical data, so which are in nominal scale. Not only the nominal scale, but also for the ordinal scale. මේක nominal විතරක් මේ ordinal data වලටත් පාවිච්චි කරනවා. The height of the bar or the size of the pie slice shows the frequency or the percentage of each category. I hope it makes sense. Okay, let's take a look at the outlook of them. So this is a bar chart. මේ bar chart එක අනිත් පැත්තට හරවපුවාම මේකට අපි කියනවා column chart එකක් කියලා. අපි bar chart එක අනිත් පැත්තට හරවපුවාම අපි ඒකට කියනවා column chart එකක් කියලා. Right? So we have this. අපි ඒකට කියනවා column chart එකක් කියලා. Savings, CD, bonds, stocks, right? So this is a column chart. Column chart. The size of the bar or the size of the column, right, depicts the amounts under different categories. So when we use frequencies and when we use relative frequencies and percentages, so here usually use right, amounts. Here usually use amounts. Frequencies. So when it comes to percentages, right, when it comes to percentages and relative frequencies, so we use a pie chart. We use a pie chart like what you see in this picture. ඔයගොල්ලෝ මේ pictures දන්නවා. ඒ නිසා මම වැඩි විස්තර කරන්න යන්නේ නැහැ. මේකේ usage එක තමයි අපි කතා කරන්නේ. Right. I hope it makes sense. Right. Let's move forward. The second thing is the Pareto diagram. The Pareto diagram is a combination of a column chart of frequencies and a cumulative polygon of frequencies. So, right, so we combine the frequencies and cumulative frequencies, right, together. So this is used to portray categorical data, to explain categorical data. So we will draw a bar chart where the categories are shown in ascending order. Please give me a minute. So now this time, so there is a difference between the bar chart in a Pareto diagram and a usual bar chart. The difference is, so with the Pareto diagram, we will order the bar charts in descending order. And we will draw a cumulative polygon, right? That is to show the cumulative frequencies. So cumulative polygon is sort of a line chart, right? That you can see in the picture later. So this is used to separate the vital few from the trivial many. Right? Okay. So let's see the outlook of this. So now I have drawn a bar chart, right, with the percentages. So we can use frequencies or cumulative frequencies, relative frequencies. අපිට relative frequency එකක් percentage එකක් විදිහට පෙන්වන්න පුළුවන්. ඒ වගේම දශම සංඛ්‍යාවක් විදිහට පෙන්වන්නත් පුළුවන්. Right. Now the percentage is here. So they are in ascending order. And so we have put the cumulative polygons like this. The cumulative polygon, right, in the graph like this. The cumulative polygon, right, help us to understand the cumulative contributions of portfolios on the investments. And the bar chart talks about the investments of individual type of investments. So these kind of the Pareto diagrams are mostly used in quality control applications to understand defects and the causes of defects. I hope now it is clear, right? There is no problem. Okay, let's try to understand. So what are the tables and charts that we use for numerical data and that we used with numerical data? So in this context, we mainly talk about the frequency distribution and the cumulative distribution of data. So which is depicted using histograms, polygons, and ogives. And in addition, we will use ordered array, stem and leaf display for this purpose. We use tables to summarize the numerical data with numerical summary measures that we will not speak in this part of the lecture. So we will be talking about it later, right? So these are the tables and right charts that we would use. Okay, first we will talk about what is an ordered array. An ordered array is a sequence of data in rank order. Okay. මම දැන් ප්‍රශ්නයක් අහනවා ඔයගොල්ලන්ගේ. ordered array එකක් පාවිච්චි කරන්න පුළුවන්ද qualitative data එක? So can we if yes, put 1. If no, put 0 in the chat box. Okay, so let me give you some more time. So please listen to this and give you answer. An ordered array is a sequence of data in rank order. It shows of the range of the data, right? The range is the difference between minimum and the maximum. Range equal, right? Range equal, this equals max minus mean. The first value in an ordered array is the minimum. The last value in an ordered array is the maximum. So this provides some signals about the variability of the data. And it helps to identify outliers. Outliers are the unusual observations, which are the observation very much away from your other data. So if the data set is large, the ordered array is not that helpful. The ordered array would be helpful for small sets of data. Okay. Now with this knowledge, so answer to my previous question, can we use an ordered array with qualitative data? පුළුවන් නම් එක දාන්න, බැරි නම් බිංදුව දාන්න. Okay, I'll give you a couple of minutes. I'm waiting for your answers. Okay, now start giving answers through chat box. Only one answer. So we have 77 people in the class. So therefore there should be 77 answers. තාම නම් එකයි. දෙකයි. තුනයි. responses නැහැ කියලා කියන්නේ ඒ අදාළ පුද්ගලයා මේ ලෙක්චර් එක ඔන් කරලා කොහේ හරි ගිහින් කියන එක තමයි. හරිද? මට response කරපු කට්ටිය හොයාගන්න පුළුවන්, නොකරපු කට්ටිය හොයාගන්නත් පුළුවන්. ඇයි මේක Zoom එකේ රෙකෝඩ් වෙනවනේ. Twenty answers. Okay, half of the class gave me an answer. පන්තියෙන් භාගයක් 150ක් මට උත්තර දුන්නා. Okay. Yes, very good. So you have given the correct. Yes, we can't use it because so we cannot order qualitative data. Okay, that's correct. Well, right? Okay, let's move forward. Okay, take a look at this, right? So at first you will see, right, an array of data. So you have been given, right? You have been given, this is an array of data. This is an array of data. Array. An array of data. We will talk about, right? We talk about an ordered array of data. Here, what we have is an ordered array. This is an ordered array. So now we will arrange our data array in ascending order from smallest to large, right? So this is the way how we get an ordered array. This is not a big thing, right? අපි මේ O level කාලේ ඉගෙන ගන්නවා. එම ලොකු scene එකක් නෙමෙයි, right? Right. So now, so this is the minimum value. This is minimum. We call this min. This is maximum. We call this max. Right? Okay. So this is the way how we get an ordered array. The next thing that we will be talking about is the stem and leaf diagram. This is a simple way to see the distribution details of a data. Right? The distribution details. Okay. Okay, let me talk about the distribution. What is meant by distribution of data? Of data. Distribution of data කියනකින් අදහස් කරන්නේ මොකද්ද? What do you know about this? Hmm? බලන්න කියන්න කවුරු හරි දාන්න කෙනෙක්. Distribution of data කියනකින් අදහස් කරන්නේ මොකද්ද කියන්නේ? මොකද්ද හැඟෙන්නේ? අපි කියනවා ව්‍යාප්තිය කියලා. දත්ත ව්‍යාප්තිය. Data distribution. We can study. So we have distributions. For both qualitative and quantitative data. So this tells you right? This tells you how likely each outcome of a particular variable can occur. If you drew, right? So if you drew one data point, one data, right? So from a population, right? How likely, right, that data to be picked by us is told by the distribution. අපි මොකක් හරි ඉන්ඩිවිජුවල් කෙනෙක් අපි පොපියුලේෂන් එකකින් ගත්තොත් අපි මයින් එකේ අගය ඒ අගය වෙන්න තියෙන chance එක කීයද කියලා තමයි මයින්. Right? Say we have a population of people with different education background. Right? අපි මිනිහෙක් randomly ගත්තොත්, so what would be the chance of that person being a person with a degree? Right? So this is given by the distribution of your data. And this is given by the distribution of your data. Okay. අපි දැනට ওই ටික විතරක් අපි කතා කරගමු. ඊපස්සේ තව we will talk more about distribution, right? What is meant by distribution of data? Okay. And the stem and leaf diagram help us to see the distribution details. Right? So if you talk about the way how we do this, the method, so we will separate the sorted data series. අපි data series එක sort කරන්න ඕනේ. Or else it doesn't matter, right? Whether it is sorting or not. Okay. So we will separate the sorted data series into leading digits and the trailing digits. The leading digits are taken for the stem, so while the trailing digits are taken to the leaves of the diagram. Okay, let me explain it with an example. So this is our ordered array of data that we took in the previous case. Okay, first take number 21. So it has 2 digits, right? One sentence. එකේ ඒවා තියෙනවා සහ 10 ඒවා තියෙනවා. The first number that you see is the first digit, and second number that you see is the second digit. The second digit, okay, no, sorry. First digit is for tens. First digit is 2, so which says 20. The second digit is 1, which says 21. We take first digit for the stem 2, and the second digit is for the leaf. So then for the 38, it is 3 and 8, and 41, it is 4 and 1. So once if we have recognized these things, we will put them in a table like this, right? To summarize the data. 2, 3, 4. We have now here 4 first digits. They are respectively 2, 3, and 4. Because we have 20s, 30s, and 40s in the data set. So we have, right, 6 20s. And we have 3 30s and 1 40s. The chance of, if we get one from this set of data randomly, the chance of picking 20s is bigger than the chance of picking a 40. So we have only 140s, right? We have only 340s while we have 620s, right, in the data set. So more chance is to pick a 20, right? A 20s. All right. So this is the way how we get it. That's the reason why, right? So we can use this. We said that we can use this to understand the distributional properties of the data. Okay, what time is it? Okay. So now it is 9:55. I'll give you 5 minutes break. විනාඩි 5ක break එකක් දෙනවා ඔයගලන්ට වතුර ටිකක් පීලා එලි පහලියට ගිහින් එන්න. Okay, take your small break. Right. So let's see how we could use other system of units. Say we have now have hundreds digits, right? Then we will be round off the tens digit from the leaves. අපි leaf එකට ගන්නේ අපි stem එකට ගන්නවා 100 digit එක. මේක stem එකට ගන්නවා. මෙයා ගන්නවා leaf එකට. මෙයා අපිට නැතුව යනවා. Right? So this is what happens. So therefore, so we get this, right? 6 for the stem and 1 for the leaf. We lose 3. So similarly for the 77, we get 7 here. And so we round it up, right, to 8. And this becomes, so this is 12. And we get this for the leaf, make a stem. So then we can summarize this set of data into a stem and leaf plot diagram like this. So we have 600, 700, so 4 700s, and we have more 800s in the data set, right? The second highest number of data is 900s. Okay, so this shows us some information about the distribution of data. So we can do this, even we can do this if we have small data sets. So if we have big data sets, it is difficult to work with stem and leaf plot, because right, if we deal with more numbers, right, so our data set will be, some of the data information will be curtailed, right? So this happens. Therefore, so this also, right, goes with small sets of data. Next, we will understand how do we tabulate numerical data to frequency distributions. The tabulating numerical data to frequency distribution. So what is a frequency distribution? So that was pretty much understood, right? That was pretty much understood early. A frequency distribution is a list or a table or a picture, so which has, right, class groupings as well as corresponding frequencies. So these are the users of a frequency distribution. So it is a way to summarize numerical data, and it condenses the raw data into a more useful form, and it allows for quick visual interpretation of the data. So we can understand, right, so what is more, what is less, right, what is most likely can happen. So those things can be pretty much understood. And the important thing is we need to break down, or we need to scale down our continuous data into ordinal data, putting classes. We set classes. So the number of classes will be decided by the researcher, the person who is constructing the frequency distribution. So once if we have decided the number of classes, we need to decide the class boundaries. So to decide the class boundaries, we need to understand the class width. The class width. So which we get dividing the range of the data by the number of desired class groupings. Usually we set class groupings to a number between 5 and 50. The class boundaries never overlap, and we would round up the interval width to get the desirable endpoints of a class boundaries. We will see it right in an example. Okay, this is a given set of data. So we have set of data. A manufacturer of insulation randomly selects 20 winter days and records daily high temperature. Now we have it. In the first instance, so what we should do is we need to convert this to an ordered array. Right now, I have ordered the data into ascending order, making it an ordered array. So then we can estimate the range. The maximum value here is the max is 58 and the mean is 12. So this is mean and this is max. The range is 46. Say the number of class groupings that we want is 5, right? So then we get the interval. We will divide 5 by 46 by 5. We will divide 46 by 5. If we divide 46 by 5, it is 9.2. So we will approximate this to the highest number, not the lowest, right? It's got a class me cinema. So this is the class with 10. The lowest limit is set at 10, right? We set the lowest limit at 10, right? We will set the lowest limit at 10, right? Because we don't have anything less than 10, right? Anything less than 10. So a lot greater than tens. So then we set the 10 as the first limit. The second limit is 20. The third is, right, 30. The fourth is 40. The fifth is 50. And sixth is 60. Nanga hayak තියෙනවා අපිට. අපිට classes පහක් ඕන නම් if we need 5 interval, need 5 classes. So we should have 6 boundaries. So it is 5 plus 1. So that equals n plus 1 boundaries, n classes nang n plus 1 boundaries. So now we have set the boundaries. So after we set the boundaries, we will estimate the midpoints. First midpoint, second midpoint, third midpoint, fourth and fifth. We have 5 midpoints. So the first midpoint is 15 NA. 10 plus 20 divided by 2, right? The third is 25th. Sorry, second is 25th, then 35, 45, and 50. So these are the class midpoints. So now we will put things in a table, right? So in the first column of the table, we will mention the classes. The first class is 10 but less than 20, 20 but less than 30, 30 but less than 40, 40 but less than 50, and 50 but less than 60. So if you take the first class, so we count 10, but we do not count 20. The 20 is counted with the second class. So if we investigate a data set, so we have 3 data points in the first class, 6 data points in the second class, 5 in the third one, 4 in the fourth one, and 2 in the last one. 50 but less than 60. එතකොට මේ දෙන්න තමයි තියෙන්නේ නේද? right? Okay. Yeah, let's see, right? So we have we have these guys, right? This is 3. And here, so we have 6 things here. And another 5 things here. And we have 4 things into the 4th class and 2 for the last class, right? So this is first one, second one, third one, fourth one, and fifth one. Okay. Now you can see it very clearly, right? What happens is clear. So now we estimate the frequencies, the total number of frequencies, the frequencies total to 20, so which is the sample size, and we can estimate the relative frequency and their percentages. Right? Okay, right. So now we can put this right on a chart, on a graph. Okay, so we can further estimate the cumulative frequencies and cumulative percentages. Or if we want cumulative relative frequencies, we can do so. So now we can put this in a graph, bar chart, so which is called a histogram, right? Which is called a histogram. So in this case, right, the class boundaries never overlaps, right? All right. So in the horizontal axis, we get the scale. So into the vertical axis, y-axis, we get frequencies, relative frequencies, or percentages as we require, right? Okay. So this is the outlook of a histogram, right? So in this histogram, we have reported the frequencies. Similarly, so we can put right. We can put relative frequencies as well. We can use relative frequencies as well. Now we have, mentioned the class midpoints in this case. So we have mentioned the class midpoints. එතකොට මෙතන ඉන්නේ 10. අපිට ඕනනම් boundaries උත් දාන්න පුළුවන්. එහෙම නැත්නම් midpoints උත් දාන්න පුළුවන්. මේ විදිහට. අපි boundaries දැම්මොත් එහෙම right here 0, 10, 20, 30, 40, 50, 60. right? අපි class boundaries දැම්මොත් මෙහෙමයි එන්නේ. Midpoints උත් ඕනනම් දාන්න පුළුවන්, boundaries උත් දාන්න පුළුවන්, but there are no gaps between bars. The so this is called a frequency polygon. අපි මේකේ ඇන්දොත් එහෙම right line chart එකක්. So it calls a cumulative polygon. Right? පහේ එකක්වත් නැහැ, 65 එකක්වත් නැහැ. We use class midpoints for this purpose. So this is called a cumulative polygon. Right? The frequency polygon. Sorry, this is a frequency polygon, right? And if you use the cumulative frequencies, right, in a graph like this, it is called a cumulative frequency. නැත්නම් cumulative polygon, so which is called an ogive. So this is the way how we summarize quantitative data using some graphs, some tables. And let's talk about how we tabulate multivariate categorical data. So they can be tabulated in contingency table. So in the body we have frequencies, right? So we have right in one column, in the first column we have one variable. In the first row we have the other variable. The first variable taken into column is the investment category, The second variable that we have taken into the first row is the type of investor. So we have now 3 investors invest in 4 different categories of investments. And we can report, right, how much they have spent given on this. So this kind of table is called contingency table. So we can have multiple graphs like this, bar charts, column charts like this without any problem. So the another diagram is called the scatter diagram. So which is called XY diagram. So which usually goes with quantitative data, right? The volume per day and the cost per day. So that we get one variable to y-axis and the other variable to x-axis, and we call this is a scatter data. The other one is time series plot, right? Other one is okay. Other one is time series plot. Hey, give me a minute, please.
சாப்பிட்டது இல்லை.
Well, so before we talking about a time series plot, so we need to talk about what are the time series data. If you don't know about that, it's hard to understand it. So what are the time series data? They are data collected on a particular variable in time with equal intervals. Example. So there are few things that you want to understand here. On a variable in time, equal intervals, right? So these are the key points that you should understand. Maximum temperature, maximum daily temperature from 2000 to 2023 in time. So this is the time period, right? In time. So this is the frequency, and you collect temperature, right? Okay, maximum temperature. One other example, weekly sales from 2010 to 2023. So now we have, so this is the time interval, sales, and the time period. So these are called time series data. So if you plot these data, so taking the time to the y-axis and your values, sorry, time to the x-axis and your values to y-axis. So this is called a time series plot. So look at this example. So you have been given annual data, right? Right, number of franchises over years. The frequency is yearly, right? We will take right. We will take year to the y-axis, year to the y-axis, and our data to the x-axis. So thereafter, so we will have a line chart like this. This is the time series plot. It's a line chart. So where time is in the x-axis and the data, the variable is in the y-axis. All right. So these are the guidelines for good graphs. So we do not distort the data and avoid necessary adornments. අපි මොකුත් add කරන්නේ නැහැ. මොනවත් අප්සෙට් එකක් දාන්නේ නැහැ. So use a scale for each axis on a two-dimensional graph. And the vertical axis scale should be begin at 0 and properly label the axis. And graph should be contain a title and use the simplest graph for a given set of data. So these are some good tips to do this. Okay, with this, I will be concluding talking about presenting data in tables and charts. So next we will be talking about how to present data with numerical summary measures. Next we talk about presenting data with numerical okay. So before talking about this, I'm going to give you again a small break to go and drink some water and get refreshed. I'll give you another 5 minutes break, right? So what are the numerical summary measures? Right? Right. These are some numbers estimate data that characterize the features of data. The features of data. Sometimes estimators of population parameters. Could you please give me a minute? So we can put our data, the quantitative data. So we can compute these summary measures on the quantitative data, right? We get summary measures, we estimate summary measures, we estimate numerical summary measures for quantitative data. So not that, right? It's for quantitative data. We do it for quantitative data. Now, note that we can put our data on the real number line. The real number line is this, right? So we have data here to the positive infinity and here for the negative infinity, right? This symbol for infinity, Anante. And here we have 0. And we can put our data on the real number. Here, real, uh, real number line. So we can have data like this. So you can place it like this, your data. So now in this data set, so this is our data set. In this data set, we can talk about the center, where data set locate on the real number line. And this area is the spread. The second thing is spread. So now we can explain the total data set, the features of the data set. We can explain the features of data set by talking about the spread and the center. The talking about the center, talking about the center is called central tendency. Talking about the spread is called dispersion. So now we can describe a data set. We can describe the data set, right? In principle, we can describe a data set we can explain a data set by describing its central tendency and dispersion. So this is what we do with numerical summary measures, right? This is what we do with numerical summary measures. Explain the data set with central tendency and dispersion. So then we will be talking about measures of central tendency and dispersion. Dispersions talk about the variability of data. Right? It talks about the variability of data. I hope it makes sense. මම හිතනවා ඔයගොල්ලන්ට පැහැදිලිව තේරෙයි. Any question after this? Anything that you didn't understand? Any question? Okay, now let's talk about measures of central tendency. Now we talk about measures of central tendency. So we talk about measures of central tendency. So there are many. Measures. We will talk about following key measures, commonly used measures. Measures of central tendency. So they are mean, median, and mode. Let's take one by one and try to understand what they are. Mean. We talk about mean. When we talk about mean, so we will first talk about population mean. So which is denoted by mu. It is a parameter. Say we collect data, right? Collect data from all individuals in the population. Capital N is the population size. Then mu equal, so please give me a minute. All right. So we can estimate mu. So by using this, so we'll add all values of the population capital N and divide them by capital N. So this can be written like this: summation I equal 1 to capital N xi divided by, right? So this is the way how we get the population mean. And then we estimate the sample mean. The second thing that we talk about is the sample mean. So which is called x bar, right? X bar, right? So we use this from sample data, estimate from sample data. This is an estimator of mu, which is the population mean. And we estimate x bar, say we have data like this. Say we have data like this. We have our data x1, x2, x3 up to x simple n. N is sample size. Then we estimate x bar as x1 plus, x2 plus, x3 plus, xn divided by simple n. This equals summation I equal 1 to n xi divided by simple n. Right? Example. Sales data. Okay. Say we have collected data, sales data, and reported here as 2, 10, 5, 3, 4, 6, 12, 8, 3, 7. So now we have data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 data points. And now we want to estimate the sample mean. X bar equal. So we add all these things together. 2 plus 10 plus 5 plus 3 plus 4 plus 6 plus 12 plus 8 plus 3 plus 7 divided by 10. 12, 17, 20, 30, 50, 60. Right? 60 divided by 10 equals to 6. So this is the sample means of sales data. Right. I hope it makes sense. It's clear. Very well done. Does it make sense? Any question up to this? Okay. The next thing that we talk about is median. Yes, we will talk about population median. So this is the value the value of population data, the value of this is the value right at the middle of the ordered population data. The place is equals to 1 minus, is n plus 1 divided by 2. So if you arrange data to data x1, x2, x3, so up to x capital N. වරහන් ඇතුළේ දාලා තියෙන ordered array කියලා කියන්නේ මේ x capital N plus 1 divided by 2 is the median. So this is the population median. Population median. Okay, similarly, we can estimate the sample median. Estimate sample median. The sample median එක කියලා කියන්නේ අර විදිහටමයි. Say, so this is our ordered data x1, right, x2, x3, xn. Median කියලා කියන්නේ x n plus 1 divided by 2. මෙයා තමයි median. This is the median. To estimate the median, right, to estimate the median, follow following steps to get median. The first one is ordered array. Second one is find the place of median, right? And third one is find the value of median. So these are the 3 steps that we estimate the median. So let's we do it, right? Let's we do it. We will do it and see. So this is our data, right? This is our data. So these are sales data. Now we will have xi. The smallest variable is 2, 3, 4. We have 2 3s. Forgot it. 3 දෙකක් තියෙනවනේ. 3 දෙකක් තියෙනවා 3. Then we have 4. Then 5, 6, 7, 8, 10, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we have 10 data points. Here the sample size is n equal 10. So now we have completed the first step. In the second step, we find the place of median. Equal n plus 1 divided by 2, that equals to 10 plus 1 divided by 2. So this is 5.5th place. Right? Now, look at this. The first value, second value, third value, fourth value, fifth value, and sixth value. 5.5th is in between this. එහෙනම් මේ දෙක අතර තියෙන්නේ somewhere here. So then we estimate the median. Right? The value at 5.5th place in 1. So this equals median equal 5 plus 6 divided by 2. It is 5.5. Place එකයි value එකයි දෙකම සමාන වුණා. එහෙම සමාන වෙන්නේ නැහැ. හරිද? සමාන තැන්වල එහෙම සමාන වෙන්නේ නැහැ. හැබැයි මෙතන මේ data set එක ඇඩිට සමාන වුණා. එහෙම නැත්නම් එහෙම සමාන වෙන්නේ නැහැ. Okay? Okay, let me change it. නැත්නම් ඔයගොල්ලෝ මේක පටල ගන්නවා. මට වෙනස් කරන්න දෙන්න එක. අය වෙනුවට මම වෙන නම්බරයක් දාන්නම්. නැත්නම් ඔක ප්‍රශ්නයක් වෙනවා. Okay. $15. So now it's correct. So now let me check it. Let me change it. This equals 6. Otherwise, it will be confusing later. So when you review the notes. Okay. Now it's correct. It's clear. Sales data. මම මේ විදිහට උඩ එකත් වෙනස් කරනවා. නැත්නම් ඔයගොල්ලෝ පටල ගන්නවා. 6 වෙනුවට මම 15 දානවා. That's fine. 6 වෙනුවට මම 15 නෙමෙයි 16 දානවා. 16 දානවා. Right? 16 දාමු. ඒකට ලේසි. 5 වෙනුවට මම දාන්නේ 16. 16. Right. So then here this will be 70. And this is then 7. Right. So now in the same data set, so this is the mean. and the median is this. They are two different values. Sometimes it could be same, but here now they are two different values. The next one is the mode. Next one is the mode. So now we will talk about the mode. The mode is the value that most frequently appear in the dataset. So look at our data. This is our data. So in an ordered array. අපි ordered array के dataset එක මේ තියෙන්නේ. So what is the most frequently appearing number? The 3 is appearing 2 times, and while rest of the things are appearing 1 time. Then the mode is equal 3. Right? So if all observations appear the same number, there is no mode. Right? Is no mode if all observations in the sample appear equal time. Sometimes there may be, right? There may be 2 modes. Right? 1, 2, 3, 3, 4, 5, 8, 7, 9, 15, 20, 20. So now 3 and 20 appear 2 times. So there are 2 modes. 3 and 20. So there may be multiple modes. There may be many numbers that appear the same number of times as the highest. So this is called, right, the multimodal dataset. All right. So next we will be talking about the measures of dispersion. Right. The most commonly used measures of dispersions are range, variance, standard deviation, coefficient of variation, CV, So we'll be talking about this, right? Under measures of dispersion. First, we talk about range. It is easy. We define range as equal max minus min. This is our example. This is our example. The maximum value is this, right? The maximum value is this. The max is this. The min is this. Okay. This is max, min. This is max. Then range is equal 16 minus 2 equal 14. So this talks about the spreads of your data. Very simple to estimate. But sensitive to outliers. So what are the outliers? Outliers are the extreme observations. Suppose, right? Suppose we had 66 instead of 16. Then range equal 66 minus 2, that is 64. The 66 is very much bigger than the rest of the value in the data set. So therefore now, so the range over-specified, right? This over-specified the dispersion. Over-specified. Right? That issue is there. This is a problem, but easy to estimate. Right? Okay, now we wanted a solution for this. Need a solution. Right? Need a solution. How to solve the problem? Komlekarani is a question, right? People wanted some solutions to do this. They define, okay, we have data. We have data. So they define something like this. They define something called deviance. Such that the I equal xi minus x bar. And they defined d bar right, as a measure of dispersion. But d bar is summation di divided by n. But the problem was this becomes 0. Therefore, a d bar becomes 0, useless. But later, as a solution, they define, right, the I squared bar as summation di square divided by n, right? So this is idea to next measure. This is the idea to next measure, right? The next measure is the variance. So they define variance as, right, is sigma squared, right, where sigma squared equal summation xi minus mu squared divided by n. So, right, this part is deviance, right? This is di. Okay. So they squared the deviance and add them together and divide it by the population size. This is not the they define variance s squared as s squared equal summation I equal 1 to simple n xi. Now we don't have mu, we have x bar squared divided by n minus 1. This is the way how we estimate the population variance and the sample variance. Okay, so we will estimate, we will do an example, right? Okay, we will work with the sales data. This is our sales data. මම මේකේ order කරන්න ඕනේ නැති නිසා මම original data set එක අරන් එන්නම්. Right? So this is our sales data. Right? So let's see. So now we need x bar. So this is x bar is 7 and sample size is 10. And s squared equal summation, right, xi minus x bar squared divided by n minus 1. Now we can do this, right? We can have we have x 2, 10, 5, 3, 4, 16, 12, 8, 3, 7. We have them, and we can get x minus x bar minus 5, 3, minus 2, minus 4, minus 3, 9, 5, 1, minus 4, 0. So we get the square value x minus x bar squared. 5, 9, sorry, 25, 9, 4, 16, 9, 81, 25, 1, 16, 0. And we need to add them together. Get the value. How much is it? 25 plus 9 plus 4 plus 16 plus 9 plus 81 plus 25 plus 1 plus 16. That is 186. 186. Okay? Right, this is it. And this part, right? Is it? So this equals to 186 divided by 10 minus 1. So this is equal to 186 divided by 9. This equals to 20.67. So this is the variance, sample variance, right? Sales data. So note that we can use another formula. So there is an easy to work with formula. Easy to work with formula. Squared equal summation xi squared minus summation x squared divided by n minus 1. අපි data square කරලා data වල එකතුව right ඒකෙන් data වල එකතුව square කරලා ඒක n වලින් බෙදලා අඩු කරලා n minus 1 වලින් බෙදනවා. අපිට එහෙමත් කරන්න පුළුවන්. Okay, that also can be done. Okay, let me shall we do it? Do we have enough time? Oh, we don't have much time. Okay, we will do it. This is our data set. අපි ඒකත් කරමු. Right? This is our data set, right? And let's get x squared. 425, 9, 16, 132. Let me 256, right? This is 256, 256, 144, 64, 949. So now we need to get the summations, right? So if you sum these things, they add to 70. And if you add these things, 4 plus 100 plus 25 plus 9 plus 16 plus 256 plus 144 plus 64 plus 9 plus 49, 676. So now we will substitute these numbers into this, and this equals to 676 minus 70 squared divided by 10 divided by 10 minus 1. If you solve this one, this will be 20.67. And this is another way of doing it. Operation ප්‍රමාණය අඩු වුණා. මේකේ අඩු කරලා ආයෙ එකතු කරන්න ඕනේ. මේකේ කෙලින්ම එකතු කරා ස්ක්වෙයාර් කරලා එකතු කරා ඉවරයි. Right? Okay, so this is the way how we do this. Okay, with this I will stop the class, right? And because I have not done this much yesterday, and we will have another class on another day, which I will notify to you to talk about the other things. අනිත් දේවල් කතා කරන්න මම තව පන්තියක් කරනවා. තව පැය දෙකක් උගන්වනවා. In a weekday, in a night. සාමාන්‍ය weekday එක රැට ඔක්කොටම පුළුවන් නේද? හැබැයි ක්ලාස් දෙකටම එකට තමයි උගන්වන්නේ. Saturday and Sunday ක්ලාස් දෙකටම එකට උගන්වනවා weekday එක. I will let you know through your course coordinator, Dr. Sashi. All right, so this completes the discussion today, and so we'll be talking more about numerical summary measures in another class. Any question up to this? Any question? මොනවද ඔයගොල්ලන්ට තියෙන ප්‍රශ්න?